6.9 Conclusion. Regression with a single regressor is vulnerable to omitted variable bias if an omitted variable is a determinant of the dependent variable and is correlated with the regressor, then the ordinary least squares estimator of the causal effect will be biased and will reflect both the effect of the regressor and the effect of the omitted variable. Multiple regression makes it possible to mitigate or eliminate omitted variable bias by including the omitted variable in the regression. The coefficient on a regressor, big X1, big X sub 1, in multiple regression is the partial effect of a change in big X sub 1 holding constant the other included regressors. In the test score example, including the percentage of English learners as a regressor made it possible to estimate the effect on test scores of a change in the student-teacher ratio, holding constant the percentage of English learners. Doing so reduced by half the estimated effect on test scores of a change in student-teacher ratio. The statistical theory of multiple regression builds on the statistical theory of regression with a single regressor. The least squares assumptions for multiple regression are extensions of the last three least squares assumptions for regression with a single regressor, plus a fourth assumption ruling out perfect multicollinearity. Because the regression coefficients are estimated using a single sample, the ordinary least squares estimators have a joint sampling distribution and therefore have sampling uncertainty. This sampling uncertainty must be quantified as part of an empirical study, and the ways to do so in the multiple regression model are the topic of the next chapter.